Hi, this is Cody Hendrickson. Today we're going to be taking a look at the structure for the project we're working on our Node project. We're using it to examine some data structures, and we've got a couple data structures we've already built. So we're going to take a look at the actual design and framework of the project so we can then hopefully get some better understandings of it as we continue working with it. As you can see right here, we have some color-coded pieces over here. On the left, we have our controller package in red. We have our framework classes in blue, and then we have our composition classes, the actual data structures themselves that we are building from them, in orange and green. And so let's go ahead and let's start with the blue for the actual data structure framework, and we'll go from there. In the blue, we got in the top right-hand corner here, we see that we have our node object. The node object is our framework object. It's one we're using to build all our other pieces, all our other components for this. And notice with the angle brackets around the word type, that's indicating it's a generic thing, aka we can put anything in here. And because we're using C++, we can literally put any kind of data type in there from int to object, or even a struct if we really wanted to. We can put anything inside that. Now, inside that node of type, we have a couple different data members. And the first data member we have is value, and that's of the type. That's the thing that we're storing inside that node. Additionally, inside the node, we have a pointer array called pointers, and it's simply just a reference to any other pointers we'd be using for that. Right now, at the node level, there's nothing inside that. That's simply just a default one. So we're looking at the idea of when we have more complex data structures, aka nodes that have more than simply just one or two pointers inside it, we can store those within an array so we can use them. And we may or may not be using that. We have an idea of doing some design in advance so we can have that ready for us. For the methods and constructors, we have our just default node constructor, which simply takes no parameters, just creates a node object so we can test to make sure that we're having that available and we can connect them if needed. We also have our get value, which returns whatever is stored inside the node, and our set value, which takes a const type ampersand value or a reference of the value so we can initialize that, and that's a void type as well. So we have a getter and setter for the type that are the main methods for our node object. Directly inheriting from node, we have our ArrayNode, and that's the first version of a node that we're using for this. It's the first one we actually use in code, and it's also typed because it is also generic. And the ArrayNode data member has a data member called next. That next is the link to another node. We use that to building either a list or an array because we have to be able to link to other nodes as part of that data structure. And so that next ArrayNode pointer is the way we do that. We also have a bunch of constructors and methods inside our ArrayNode object. We have three different constructors we have with the ArrayNode. We have our default constructor with no parameters. It simply creates an ArrayNode that we can use to initialize as we need. We also have an ArrayNode that we can initialize with a specific value. And we have an ArrayNode we can initialize with a value and a pointer for its next node. So we can immediately create and initialize it with a link to the next node at one time. For methods, we have two different methods we're using for that, the idea of getNext and setNext. The setNext method takes a pointer to another array node, so we can replace whatever is inside that current array node as its next, so we can link it to a new node. And the getNext returns whatever node we're currently pointing to. And so that way we can actually retrieve and get values out of our list by pointing to the associated nodes with that. Looking over here to the right, we have our implementation of those array nodes. We have two different ones. We have in static with orange, we have our CTEC array, which is a static sized array. Now this array is not a hipster array, it has actual methods and data members, and it's looking more like a structure we will use. We have inside that array, we have a data member called head. That head data member is how we keep track of the actual data structure internally, how we are able to iterate over it and find all the data, components. That head data member is a node pointer. And so it's an array node pointer specifically because it's simply a reference to where that array starts. We also have a size data member. And again, this is a non-hipster array, so it's a private data member. That's of type int, representing how big that array is. And because this is an array that is a static size, that can only be initialized when we first create our object. We see that right here with our constructor with CTEC array, takes an int size, which initializes and builds all the associated array nodes, linking them together at the beginning, so it's available. We have our destructor, which takes care of removing all those components from memory when we're done with that data structure. And then within our array data structure, we have two methods. We have get and set. And keeping with the idea that our array is a special case, our set method does not return a type. It is simply a void type method, where it replaces whatever is originally stored inside that data structure with that new value. And we also have our get, which has a type, and it simply just returns whatever was stored at that specific index. Looking on the green, just below that, we have our more advanced data structure, our list. And our list has a few more data members for that. It has a size data member as well as the head, same idea of a pointer. But in the idea of a list, we also have a pointer to our end. And even though this is simply a singly linked list, that end pointer allows it so we can easily use both the front and the end for both adding and removing from the data structure immediately. On our constructor is even simpler. So it takes no parameters because it simply initializes the head and end pointer to be null and the size to be 0. Our destructor will take the job of actually going through and removing all of those different array nodes within our list and destroying the memory allocation for each of them. We have our get size because, again, we're using an idea of having a getter, and it matches the idea of a get and then the size for the data member name, so keeping that idea with it. And then in the methods we have for the actual list itself, we have a bunch of adds where we can add either to the front, to the back, or at a specific index. And we have our gets, getting from the front to the back or a specific index, as well as removes from the front to the back or at a specific index, and then set where we can replace an individual value. If you notice, for all these ones that we were using on this, we have the idea of the const type ampersand value because, again, we want to make sure we do not destroy the data when we pass the parameter of a value for that. And when we're working with the idea of an index, everyone that has an index as a method name will have a data member, every method that has index as part of its method name, all those methods will also have a parameter of index because we are replacing, getting, or removing a value at that specific spot. So it's a nice way to keep track of that. And so we have the idea, again, right here, when we look at the composition relationship, that as you can see right here, we have 0 to n on that composition relationship, that our array and our list both are made up of anywhere from 0 to n number of array nodes, so that they are actually composed of those different pieces. Looking over here on the left-hand side in the red, we have our controller package, where we're actually doing the stuff with that. The first thing in our controller package, of course, is our runner, and we have our main, which all our main does is simply contain a reference to a node controller because we keep our mains very simple and clean, so we don't have to worry about trying to fix them later. Looking at our node controller, we have some data members in there. We've created references to our array vis-a-vis a string array and an int array. Notice that we have it with a nice easy memory of that int array and string array as the actual name for that, and where it's a ctick array of type int or a ctick array of type string. And then with that, we also went a little bit further and we made a reference of that with our list using an int list and a string list. And again, because we are using C++, we can have any type of data structure. So our list structure can be using primitive type values like an int as well. Inside our controller, we have one method start, the standard method we use in all of our controllers from C++ and Java that starts up our code and gets it going. And we have a constructor and destructor if we need to remove any values and load up the initial values for all of our components. And then we have a couple helper methods with this where we can actually set up the list and set up the array as we actually load those values in there, so we can go and test them as we actually build our projects. So here we have a quick little analysis of how our actual node project is going so far. We have over here in the blue, we have our node and our ArrayNode, the framework type that we're using to build from this. This is the parent class, this is the child class. We have the implementation of that with our ctick array and ctick list. Both of these are also generic types as indicated by the type inside angle brackets. And then we have our controller, which is running all that code and taking care of all of this. So we have a quick little framework right here. We're going to be continuing on with this by adding to this with a double linked list and then extending the idea of list to be using sets and stacks shortly. So keep looking in on what we're doing. We'll help to see you here and have some fun. Thanks and have a great day.